Okay, back for our last video on torque. We already talked about two different ways to calculate torque when the angle theta is not going to be equal to 90 degrees. We talked about just finding the angle between R and F. We talked about using the component of F that is perpendicular to R. Hey, I've been reading Harry Potter. Sorry, forgot that was there. And the final way that we could do this is to use what is called the line of action method. The line of action is an imaginary line that overlaps and is parallel to the direction that the force is acting in. So again, in this case, we had someone pushing up on this lever straight up. The lever's at a 60-degree angle to the vertical right here. So we have this. There's their force. The line of action is an imaginary line, which I'm going to draw in as a dotted line. It goes up like this. Okay? That's the line of action. Now, after drawing your line of action, what you're going to do is find the spot where it is closest to the axis of rotation. And through kind of a neat geometrical trick, where is this line closest to the axis? Right here. Okay? Right at this point right here. So that is also where hold on a sec, let's see, the new R, so if we imagine this to be the new R, the distance or the spot where R, or where the line of action is closest to the axis of rotation, look at the angle that the force and the new R have. It's a right angle, okay? The new R will be perpendicular to the line of action, which is parallel to the force. So, using the line of action method, theta will always be 90 degrees, and the sine is therefore 1. So what you get is T equals R times F times sine theta. You can calculate the tau, I should have said tau, not T, by using R perpendicular. Okay? That means this right here. This is R perpendicular. Okay? This the original R was 2. We're using the R, the component of R that is perpendicular to the force and therefore our line of action. We need to figure out how big this is right here. So what I would do is I'd think of it this way. If this is a 60-degree angle, that's got to be a 30-degree angle. Here is the original R. This is kind of like the X component of that. So R perpendicular is equal to 2 meters multiplied by the cosine of 30 degrees. I suppose you could also use sine of 60, but I used the cosine of 30 degrees. It should give you the same thing. If I plug that in, 2 meters times the cosine of 30 degrees times the force of 50 newtons, once again, you will see the following. It should be equal to what we got the first time. Let's do 30 cosine times 2 times 50, and we still come up with a tau, a torque, of 86.6 newtons per meter. So this is the same as what we got before. That was the whole point in showing you this. Our conclusion is that there are 3 different ways to calculate torque. Either finding the angle between R and F, using for the force the component of the force, only the component that's perpendicular, or using the line of action method, in which case you find R perpendicular. There are 3 different ways to calculate torque. Each is useful in different situations. So the reason I've shown you all these is because in different situations, one might be more useful than the others. I'll be honest, I think the first one is usually pretty easy to do, but there are cases where using the line of action or figuring out the component of the force that is perpendicular to R has helped me in the past. When I went through and wrote the answer key for all the homeworks, I actually used all three of these methods at one point or another, which is why I'm showing you all of them. So that is it on torque. Torque on its own is really not that bad. Calculating torques is not hard. Putting it all together in a free body diagram, that can be a little tricky, but it's not, I mean, the process is very similar to writing a net force equation after drawing a free body diagram, okay? So the more, it's the same thing as everything else. The more you practice it, the better you'll get at it. After we study torque for a little bit, what we're going to move on to is rotational dynamics, which is similar to what we've been doing with the extended free body diagrams, but a little bit more in depth. We'll talk about objects that roll, and then we'll talk about angular momentum. So we really have like three more like mini units to hit before we're done with rotational motion. Knowing about torque is the way to understand all those other ones, okay? If you have any questions, don't hesitate at all to ask me. This is tricky. It's especially tricky to learn without me there. So please ask questions whenever you have them. All right? Hope everyone's doing well. Hope I can see you guys soon. Bye.